right, today we're going to talk about how to solve radical equations, and this is also known as rational exponents equations because we just got done talking about how to take a radical expression and rewrite it as a expression that has rational exponents. And so what we can do is we can actually take radical equations, rewrite them with rational exponents, and solve them. So I'm going to show you first how to solve a simple radical equation with its, if it's a square root. And then we're going to talk about a little more advanced problems when you have rational exponents, maybe like the cubed root of something squared. We would rewrite that as a rational exponent to solve it because it would be a lot easier to do. All right. So first we're going to look at radical equations that are square roots only. And so I'm just going to put some examples up here and we're going to walk through how to solve these. So if you have an equation that contains a square root, this is a type of radical, but if it's just a square root, what you do is you isolate the radical sign. What that means is to get this radical completely by itself. So I want this by itself. So the 2 would have to move by adding it. And so that would give me radical c plus 3 equals 6. Because we have isolated the radical, we are now ready to solve. So the first step is to isolate, and then you have to get rid of that radical. And the way that we get rid of that radical is we do the opposite of square root, which is to square. So to undo a radical, you square. More specifically, to undo a square root, you square. Because we're going to look at other radicals in which we have to do the reciprocal for, but we'll talk about that in just a second. All right, so what I end up with is c plus 3, because the square and the square roots cancel, equals 36. And now I'm ready to solve this by moving my 3. By subtracting it, I get 33. You want to make sure you check your work to plug your answer into the original problem to make sure it works. So a little mental math here. We've got the square root of 33 plus 3 minus 2. We want to know, does that equal 4? So 33 plus 3 is 36. The square root of 36 is 6. 6 take away 2 is 4. It works. So on these types of problems, you really want to check your work to make sure that your answer makes sense, especially if you get a problem in which you get 2 solutions. Sometimes they both work and sometimes only one works. So let's take a look at another example. This is going to be another square root problem. If I have the square root of x plus 1 equals x plus 1. All right, so my radical is isolated. I don't have anything in front of it or behind it, so I am ready to take the square of both sides. Remember, we square both sides in order to eliminate the radical sign. So that will give me x plus 1 equals, now with this part here, I'm going to have to FOIL. So right over here, we're going to have to say x plus 1 times x plus 1. And that is x squared plus 1x plus 1x plus 1, x squared plus 2x plus 1. That is a perfect square trinomial. We talked about that when we solved quadratics. The shortcut there is you can square the first term, double the middle, which is 1 times x doubled is 2x, and then square the last term. Or you can always just FOIL. All right, to solve this, if you notice, it's a quadratic because of the x squared, so I have to set it equal to 0. So I'm going to subtract 1 and subtract the x. So I get my 0 equals x squared plus 1x plus 0. I don't need that 0, so I'm just going to get rid of that. And to solve a binomial, you can take out the GCF. The greatest common factor is x. So when I divide my problem by x, I get x plus 1. Split, set equal to 0. And this is all solving quadratics. We talked about how to solve them by factoring our previous unit. So I x to be 0 and x to be negative 1. So we want to check these answers because maybe one works or maybe both work. So I'm going to plug it into my original problem and see if they work. Whoops. It's definitely not a 0, it's a 1. So when I plug in a 0, I get 0 plus 1, which is 1. Square root of 1 is 1. On the right-hand side, I get 0 plus 1, which is 1. So that answer worked. So now let's try negative 1. So I'm going to get rid of my 0, and I'm going to plug in a negative 1 and see if it works. Negative 1 plus 1 is 0. The square root of 0 is 0. Negative 1 plus 1 is 0, and we know 0 equals 0. So both of these solutions work. So a quick recap, if it's a square root, to solve a square root, so a radical with an index of 2. Radical with index of 2. To solve that, you would isolate the radical sign, then you would square both sides, and then solve for your variable. Always check your answer, okay? So if you are trying to solve a square root equation, you're going to isolate first, square both sides, and then solve for your variable. And then, of course, check your answer, especially if you have two. If you have two answers, check both of them. Sometimes they both work, sometimes only one works, sometimes none of them work. And those are called extraneous solutions. If you get an answer that does not work, it's called an extraneous solution. Okay, so now let's move on to equations that are radical, but they're just not simple. They're not just square roots. They're going to have maybe a cubed root, or they've got a root of 5 and an exponent of 2, just some crazy looking stuff. And I call those my other radical equations. So these are just simple square roots, isolate, square, solve. Now we're going to look at crazy looking problems. They're not that bad. These are actually pretty cool. So the best way to do that is to jump straight into an example. So I've got 3 times x plus 1 to the 3/5 plus 1 equals 25. Okay, so this is a rational exponent equation, and sometimes they may give this to you written as a radical, like this. If they give it to you as a radical, I would definitely rewrite it as a rational exponent. Okay, so anytime you have a radical and it looks really strange, like this one right here looks really complex. It's not that complex, but it looks very complex. So if you get a problem that looks very complex like this, rewrite it using rational exponents. And of course, that would be the radicand, the x plus 1. Inside the parentheses, the exponent goes on top of the fraction, and the index goes on the bottom of the fraction. So if you have a radical equation and it looks wonky, rewrite it as a rational exponent. It's going to make your life a whole lot easier. All right, with that being said, same idea. We are going to isolate this part of my equation. I want this to be by itself, which is the rational exponent part. We want that to be by itself. So I have to get rid of this 3, and I have to get rid of the plus 1. So just like if you had 3x plus 1 equals 25, who would you move first? That's right, you're going to move the 1 first. So that's what we're going to move first. We're going to move this 1. So I get 3 times x plus 1 to the 3/5 equals 25, and remember when you're moving this 1, you're going to subtract it. So that's 24. You with me? Okay, now I'm ready to move this 3. This is 3 times the x plus 1. So undo times, we are going to divide. So the 3's cancel, and now I have my x plus 1 isolated like the plan was. 24 divided by 3 is 8. All right, so we have isolated this radical, or this, in this case, my rational exponent. So once I have isolated it, now I'm ready to solve. To solve these types of problems, you are going to multiply, or to raise the, instead of squaring both sides, we are going to do the reciprocal. Remember, reciprocal is a fraction flipped. So we're going to take that rational exponent and we are going to flip it. So this thing flipped is 5/3. And what you do to one side, you have to remember to do to the other side. So we are going to raise both sides to the reciprocal. And when we do that, the fraction here will cancel. Because the 5's will cancel, the 3's will cancel. 3/5 times 5/3 is 1. So that will cancel, and that leaves my x plus 1. Equals. Now this is where a calculator will come in handy. So I can take that 8 and raise it to the 5/3 power and see what my calculator gives me. So I'm going to open up my calculator here and take 8 to the 5/3 power. So 8, and I used the little caret key that's under clear, and I typed in my fraction, my rational exponent of 5/3, and I get 32. So I know that this is 32. To solve for x, we need to move that 1 over by subtracting it, so x equals 31. And you would check your answer by plugging that in, and you can do some mental math, but most times with these odd-looking radical equations, you don't need to check your answers. It's just with the square roots. All right, so let's take a look at another example. Let's do another fun one. I like those. I think they're fun. But then again, I like puzzles and those sorts of things too. So if I have 3 times x plus 1 to the 2/3 power equals 12. All right, so again, I want to isolate this part of my equation because it's the part that has the rational exponent on it. So I need to get this by itself. So I have to get rid of the 3. That is 3 times. How do you undo times? That's right, you're going to divide by 3 on both sides. So this will give me my x plus 1 to the 2/3 power equals 12 divided by 3 is 4. So I have isolated my rational exponent part of the problem. And now I'm ready to get rid of my rational exponent by doing the reciprocal. So there is my reciprocal. Now I have one little note to add here. Note, this is a huge important note. If your reciprocal has an even denominator, then do plus or minus. Okay, so in this case, if you notice, my reciprocal that I'm raising both sides to, that 3/2, has an even denominator. So I'm going to have to do the plus minus. Now the last example had an odd denominator. So if you take a look here, when I did my reciprocal, that number here was odd. So I didn't do plus and minus. But this reciprocal has an even denominator. So I'm going to have to do plus and minus whenever I figure out what 4 to the 3/2 is. So that's a very important note. Just make sure if you flip and your denominator is now even to do the plus and minus. All right, so this x plus 1 falls out. 4 to the 3/2 power, I'm going to go to my calculator. 4 caret to the 3/2 power gives me 8. So this is plus or minus 8. To solve this equation, I'm going to move my 1 over. So x equals -1 plus 8 and minus 8. So I need to simplify that just like we did with our square roots, our quadratic functions. So that gives me a -9, and that gives me a +7. So remember, if the flipped fraction has an odd denominator, don't do plus minus. If it has an even denominator, that's when you do the plus minus. All right, now let's do one more example, because I know y'all love examples. This one's going to be 2 times the 5th root x plus 150 to the 3rd power minus 30 equals 24. All right, do you remember what I said earlier about a funky looking radical that's not a square root? Let me back up. Okay, do you remember this slide here where I said if it's written as a funky looking radical, what are we going to do? That's right, you're going to rewrite it as a rational exponent, because that's going to make your life a whole lot easier. So I'm going to rewrite this as x plus 150. Now what would my exponent be? Have to take a look at your index and your exponent. How would you write that rational exponent? Do you remember? That's right, the index goes on the bottom and the exponent goes on the top. So that is 3 over 5. So make sure you know how to write a rational exponent given a radical. All right, so now I'm ready to go. I need to isolate the stuff that's in the parentheses. So the 2 and the 30 have to go, but it's got to go in a particular order, just like you solve an equation. So I'm going to move the 30 first by adding it. So I get 2 times x plus 150 to the 3/5 power equals 54. Now I got to get rid of my 2. How do I get rid of that 2? That's right, you got to divide by 2. So x plus 150 to the 3/5 power equals 54 divided by 2 is 27. All right, so now I'm at the point where I have isolated. Got to get rid of that rational exponent. So how do I get rid of that rational exponent? You're going to raise it to the reciprocal. Take a second here. Take a look at that reciprocal. Am I going to use a plus and minus? Nope, because the bottom is an odd number, so I don't need plus and minus. So I just drop my x plus 150 because remember that will cancel. Need my calculator here, so I'm going to put in my calculator 27 raised to the 5/3 power. And I get 243. 243. Now to solve, you're going to subtract 150, so x equals 93. And this is not a square root problem, so I don't need to worry about checking that answer. It'll work. All right, so that is how you solve rational exponent equations. If it is a square root, you simply isolate and square both sides. Make sure you plug your answer in to check it. If it is one of these other complex looking radical equations, then you would rewrite it as a rational exponent. Isolate. To get rid of that rational exponent, you multiply by its reciprocal. So here's where I multiplied or raised it to the reciprocal. Whoops, I can't even spell. And then you just solve. So here we rewrote as a rational exponent. Then we isolated that stuff in the parentheses. And then we ended up doing the reciprocal, and then we solved. So that's how you solve these problems. I don't like that rewrite. So rewrite using a rational exponent, isolate the parentheses stuff, reciprocal to get rid of that rational exponent, and then solve it. If it's already written as a rational exponent, then you're ready to isolate and then do the reciprocal. Remember, if the reciprocal is an even number, put the plus and minus. Very, very important note there. And then there it was an odd, so we didn't have to do the plus and minus. And then back to the simple square roots. Be careful here because sometimes you do have to do some solving quadratic stuff, like factoring to solve it. Those are more complex ones. And that's just your basic simple one. All right, so I'm going to give you a problem, and I want you guys to try it and see if you can get it correct. So let me see if I can get me another blank slide here. think it only gives me 5. Oh, yes, 6. All right, so I want you to try this one. So you will pause the video, work it out, and unpause the video and see if you get the right answer. Let me find one. Square root of b minus 5 equals 4. So pause the video, work that out, unpause the video, and see if you got it correct. All right, so you are back. This is a square root. Simple square root means I would square both sides to solve it. So b minus 4 equals 16. Add the 5. b equals 21. Plug it back in mentally, check that works. So 21 take away 5 is 16. The square root of 16 is 4, so that works. All right, try this one. T minus 3 to the 1/3 power equals 2. Pause the video, work that problem out, and then unpause it and see if you got it right. All right, so we are back here. We are ready to, it's already isolated, so I'm ready to get rid of that third. The reciprocal is 3/1, which is the same thing as 3. So t minus 3 falls out. 2 to the 3rd power is 8. Add the 3 to solve it, and I get 11. So hopefully you ended up with 11 there. All right, let's try another problem here. Let's do 2 plus the square root of 3p plus 7 equals 6. So go ahead and give that one a try. Pause the video and then unpause it when you've got your answer and see if you got it correct. All right, this one I need to isolate the radical. So we should have moved the 2 over. And we have 3p plus 7 equals 4. So I'm now ready to square. To get rid of a square root, we square. So 3p plus 7 falls out. 4 squared is 16. Subtract 7, I get 9. Divide by 3, and my answer is 3. So hopefully you got your answer there to match mine. All right, let's try another problem here. This would be number 4 on your turn. Give this one a go. We're going to do 3 plus 4 minus x to the 3/2 power equals 11. So copy that problem down, pause the video, work it out, and see if you get what I get. All right, so now you are going to check your work. I'm going to subtract 3 because we want to isolate the part of the problem that has the rational exponent. So I get an 8. I am now going to raise this to the reciprocal, which is 2/3. 2/3 has an odd denominator, so I'm not going to put the plus minus. So I get 4 minus x equals 8 to the 2/3 power. Use my handy dandy calculator here. I get 4. To solve this, we're going to subtract 4. So negative x equals 0. Divide by negative 1, x equals 0. Hopefully that is the answer that you came up with as well. All right, we're going to do one more problem. Let's do 2x plus 3 to the 3/4 power minus 3 equals 5. So jot that down, pause the video, try it, and then unpause and check your work. All right, so you are back. You are checking your work. So I got 3 to the 4th power. We added the 3, and we got 8. We're going to multiply by the reciprocal because I have isolated that ugly fraction there, or parentheses stuff. So the 2x plus 3 falls out because the exponents cancel. 8 to the 4/3 power is 8 to the 4/3 power is 16. Subtract 3, you get 2x equals 13. And then you're going to take half of that and you get 13 halves or 6.5. I was looking at my answer key to make sure that was right. Sometimes I even panic when I get a fractional answer, but don't do that because you can have fractional answers in these as well. All right, so hopefully you have seen plenty of examples there, enough to figure out your worksheet. There's 10 questions on there. Remember just to isolate that radical or isolate the parentheses part of the problem that has the rational exponent on it, and then get rid of that rational exponent by using the reciprocal, and then solve. And let me know if you guys have any questions, and I will see you guys next week.